About the next functional group, which is alcohols. Okay, so which is alcohols. ALCOHOLS, alcohols. Okay, right. The functional group present in alcohols is OH. OH group is the functional group. If OH group acts as the functional group in the organic compounds, then that compound is called as an alcohol. So like alkyl halides, the general structural formula for alcohols can be given as R bond OH. R bond OH. In halide compounds, X will be present instead of this X, OH. Let us substitute what? OH. Okay. So how many hydrogens, how many carbons, and how many oxygens will be in alcohols? If n number of carbons are present, then how many hydrogens actually? 2n plus 1 plus 1. So 2n plus 2 and 1 oxygen. 1 oxygen. So Cn H2n plus 2O. So this is the general molecular formula for alcohols. Okay. So in alkyl halides, in the structure, instead of X, let us introduce what? OH group. So instead of this X, OH. 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 So now, so these are called as what? Alcohols. Okay. So this is the general structural formula. It can be. Okay. And the molecular formula will be for CH3OH, CH4O is the molecular formula. For C2H5OH, C2H6O is the molecular formula. And for C3H7OH, C3H8O will be the molecular formula. And what about C4H9OH? So C4H10O. C4H10O is the molecular formula. Okay. Okay, let us continue. Let us see the structures. Okay. So in halide compounds, halogen will be present. So instead of this halogen X group, let us substitute what? OH group. Then only those compounds are called as what? Alcohols. Okay. Right. So I have removed all the halogens present in these groups. So after the removal of this halogen from this group, now these groups are called as what? Alkyl groups. What? Alkyl groups. Okay. So with alkyl groups, OH group must be attached. So in the first compound, I introduce OH. Here also OH. Here also OH. 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 All compounds have OH as the functional group. So these compounds are called as alcohols. Okay. Right. So these are all alcohols. So we have finished this structure. Okay. Right. And what about the common name? Common name for halide compounds, for alkyl halides. The common name is what actually? Alkyl halides. Alkyl group attached with halogen. Those compounds are already we have finished, which were called as alkyl halides. Now instead of this X group, we have introduced OH group. So for OH group, alcohol is the name. For OH group, alcohol is the name which should be given in the common name. Common name. Okay, right. So the general common name for these structures is alkyl alcohol. Alkyl alcohol, simply. Okay, if the alkyl groups are aliphatic, all are aliphatic, so the general common name will be alkyl alcohol. Alkyl alcohol. Okay, right. So accordingly, let us write their common names. I am removing all the halides. In the halide compounds, alkyl halide. We are removing that halide. Instead of that halide, what we have introduced? We have introduced alcohol. Okay. Okay, so the first compound, CH3 is methyl, OH is what? Alcohol. So this is methyl alcohol. CH3OH, methyl alcohol. What is the molecular formula for methyl alcohol? CH4O. The structure is CH3 bond OH. The common name is methyl alcohol, alkyl alcohol. Alkyl group is methyl, OH group is now called as alcohol. So methyl alcohol. And for the second compound, CH3CH2OH, CH3CH2 or In the combined form C2H5. This group is called as ethyl. OH is what? Alcohol. So the second compound is ethyl alcohol. Okay. The molecular formula for ethyl alcohol is C2H6O. Okay. Right. So the common name is what? Ethyl alcohol. C2H5 is shortly written as ethyl. C2H5 actually it is expanded as CH3 bond CH2. Its name is what? Ethyl. OH is alcohol. Okay. And the next compound C3H8O is the general formula, that is general molecular formula. In this C3H8O, the alkyl group present is C3H7. OH is the functional group we can write. So OH is the alcohol. So already we have seen there are two different types of propyl groups. So the one is N-propyl, another one is what? Isopropyl. Okay, so N-propyl and isopropyl, we all know very well about isopropyl. When the name iso will come, whenever CH is bonded with two methyl groups, whenever CH is bonded with two methyl groups, now this group is called as iso. Okay, so total 3 carbons, prop being an alkyl group, it ends with YL. So the first one is N-propyl, the second one is isopropyl, OH is alcohol. So the first one is N-propyl alcohol and the second one is isopropyl alcohol. Okay, right. Okay, so the next one, the general molecular formula C4H10O. Okay, the alkyl groups present in this C4H10, since it contains 4 carbons, there must be butyl groups. There must be butyl groups. Already we know there are 4 different types of butyl groups. 4 different types of butyl groups. These are the 4 different types of butyl groups: N-butyl, isobutyl, secondary butyl, tertiary butyl. Okay, the first one, with N-butyl group, OH is attached. So this is N-butyl alcohol. In the second compound, with isobutyl group, OH is attached. So it is isobutyl alcohol. So N-butyl alcohol, isobutyl alcohol. And the third one is secondary butyl alcohol. Secondary butyl alcohol. Okay, the last one is tertiary butyl alcohol. So this we know very well, isn't it? So there are 4 butyl groups. So how many alcohols are present in the molecular formula C4H10O? 4. What are they? N-butyl alcohol, isobutyl alcohol, secondary butyl alcohol and tertiary butyl alcohol. Okay, right. If an alcohol contains CH2OH in its structure, then it is called as primary alcohol. If the structure has CH2OH, then it is called as primary alcohol. If the structure has CHOH, then it is called as secondary alcohol. If the structure has COH, then it is called as tertiary alcohol. So based on this, we can classify N-butyl alcohol. Since it has CH2OH, it is a primary alcohol. Isobutyl alcohol, it also has CH2OH. So it is also primary alcohol. Primary shortly represented as 1 degree. Okay. Now this alcohol, it contains CHOH in its structure, CHOH. So it is secondary alcohol. Secondary alcohol. CHOH means secondary alcohol. COH. So it is tertiary alcohol. Okay. So the molecular formula C4H10O has 4 different types of alcohols: N-butyl alcohols, isobutyl alcohol, secondary butyl alcohol, tertiary butyl alcohol. How many primary alcohols are present in the molecular formula C4H10O? How many? 2. What are they? N-butyl alcohol and isobutyl alcohol. These 2 are primary because they contain CH2OH. Okay. So actually, OH is the functional group. The carbon which is directly bonded with functional group is always called as alpha carbon. Always called as alpha carbon. What is alpha carbon? The carbon which is directly bonded with functional group is called as alpha carbon. And the hydrogen atoms which are directly attached with alpha carbon are called as alpha hydrogen. Alpha hydrogen. Always primary will have 2 alpha hydrogens. Primary will have 2 alpha hydrogens. Secondary will have only 1 alpha hydrogen. And tertiary does not have any alpha hydrogen. So there is no alpha hydrogen present in the tertiary alcohols. Okay, right. So these are what types of alcohols. What about N-propyl alcohol? Is it primary or secondary? Yes, N-propyl alcohol, this is the structure, it has CH2OH, this C is alpha carbon and these are alpha hydrogens, so it has 2 alpha hydrogen atoms, so it is primary. What about isopropyl alcohol? Isopropyl alcohols, it has CHOH, alpha carbon, only 1 alpha hydrogen, so it is secondary. It is what? Secondary. What about ethyl alcohol? C2H5OH. If you see C2H5, you may confuse. You just see the above structure which has CH3CH2OH. In this, you can clearly see that this compound has CH2OH. So this is alpha carbon. There are 2 alpha hydrogens, so it is primary. So ethyl alcohol is primary, N-propyl alcohol is also primary. Isopropyl alcohol is secondary. Isopropyl alcohol is a secondary alcohol, whereas isobutyl alcohol is a primary alcohol. Isopropyl alcohol is a secondary alcohol, but isobutyl alcohol is a primary alcohol. Interesting, na? Yes. So simply just by seeing the name itself, if the name has iso, then it will be secondary. If you consider like this, means it may wrong. Okay, right? So isopropyl alcohol is a secondary alcohol, whereas isobutyl alcohol is a primary alcohol. Isopropyl alcohol contains CHOH group, whereas isobutyl alcohol contains CH2OH group. Okay, right. What about methyl alcohol? Methyl alcohol, this is alpha carbon, these are all alpha hydrogens. It has 3 alpha hydrogens. 3 alpha hydrogens. So based on the properties, it behaves like what? Primary. It behaves like what? Primary. Okay, right. Okay. So like alcohols, we can classify alkyl halides also. If an alcohol contains CH2OH, it is primary. Like that, if an alkyl halide contains CH2X instead of OH, X. So CH2X means primary. If an alkyl halide has CHX in its structure, CH bond X in its structure, it is secondary. If an alkyl halide has C bond X means tertiary. So instead of OH group, if you place X group, then we can say the same as that of alcohols, whether primary, secondary or tertiary. Okay, right. So both alkyl halides and alcohols have similar structure and similar common name. Similar structure and similar type of common name. Okay, if X is present, it is halide. If OH is present, it is alcohol. That's it. Okay, right. Let us enter into the IUPAC name. IUPAC name. For halo compounds, for alkyl halides, how was the IUPAC name? How we have written the IUPAC name actually? So for halo compounds, the IUPAC name, the root word is always alk. Root word is what? Always alk. Okay. And if single bonds only present means ane, double bonds means ene, triple bonds means ine. Ane, ene, ine. Single, double, triple. Isn't it? Okay. For halo compounds, the word halo was written as prefix. Prefix means the word which comes just before the root word. Here hulk is the root word. Just before it, we have written halo. So halo was written as a prefix in halo compounds. But in alcohols, if the compound has OH as the functional group, always if OH is present as the functional group, then that OH is written, then in the IUPAC name, that OH is written at the end. And the IUPAC name of that OH group is all. What? All. Since the word alcohol ends with ALCOHOL, the last two letters. So alk and all. Alk and all. Single bond means, double bonds means alkenol. Double bond means, triple bonds means alkynol. So always root word first, then ene, and then what? All. So if OH is present as the functional group, then that OH is written at the end and the name OL is given to the alcohol group. Okay. In some cases, OH may not be considered as a functional group, because in those cases, the functional group which have more preference than alcohol group may be present. In those cases, OH group can be considered as what? Substituent group. If any group which has more priority than OH group is present, in those cases, OH group is considered as substituent group. In those cases, OH, the name, IUPAC name for OH is written as a prefix that is before the root word alk. Okay, if OH only present or OH has the preference than other groups, if the IUPAC name of OH is all, it is written at the end as a suffix. Okay, the preference order we will see in the later classes. Okay, in this class, let us see OH as the functional group only. Okay, so for methyl alcohol, the root word, it has only one carbon. The root word is what? Meth. Since it has one carbon, the root word is meth. No double bond. So, and for OH group, all. So, meth and all. Meth and all. Methanol. Meth and all. Methanol. And for ethyl alcohol, it has two carbons actually. So, the root word is eth. No double bond. So, and OH all. So, eth and all ethanol. So, for methyl alcohol, the IUPAC name is methanol, and for ethyl alcohol, the IUPAC name is ethanol. And for N-propyl alcohol and isopropyl alcohol, what is the difference between these two in their structure means the position of OH group changes. In N-propyl alcohol, the OH group is present at the corner carbon, whereas in the isopropyl alcohol, the OH is attached at the middle carbon. Okay. So, in these cases, we have to clearly mention the position of the OH group as they are different. Okay. So, for N-propyl alcohol, OH is attached at the first carbon. Always numbering should be started from the end in which the functional group has or the substituent will have the lowest number. Isn't it? Always the numbering should be started from the end in which the functional group or substituent gets the lowest possible number. Okay, fine. So, in this case, OH, if you start from here, OH will get number 1. If you start from here, OH will get number 3. So, we have to follow the second rule, lowest locant rule. The continuous carbon chain has 3 carbons. So, prop, no double bond. So, and OH is at the first carbon. Okay, so prop and all, propanol, prop plus and plus all. So, which is propan 1 all, propan 1 all, propan 1 all. And for isopropyl alcohol, OH is at the second carbon. So, 3 carbons. So, prop, no double bond, and OH is at the second carbon. So, propan 2 all, propan 2 all. Okay. So, propan 1 all is N-propyl alcohol, propan 2 all is isopropyl alcohol. Propan 1 all is a primary alcohol, whereas propan 2 all is a secondary alcohol. Okay, right. Let us see about butyl alcohols. N-butyl, isobutyl, secondary butyl, tertiary butyl. So, there are 4 butyl alcohols. So, N-butyl alcohol, here also we have to clearly mention the position. Already we have seen this in the case of halo compounds. Okay. So, the position of OH is number 1. So, totally 4 carbons. So, lowest locant rule we have to follow. So, 4 carbons means but. No double bond between carbon atoms. So, only single bond. So, and OH gets the number 1 position. So, 1 all. So, butane 1 all. For N-butyl alcohol, the IUPAC name is what? Butane 1 all. Butane 1 all. Okay, right. And for isobutyl alcohol, here also we have to clearly mention the position. If you start from here only, OH will get the lowest possible number. So, first carbon has OH group and second carbon has methyl group. 1 OH, 2 methyl. So, first we have to write the substituent. Here which is substituent? Methyl. With which carbon it is attached? Second carbon. So, 2 methyl. So, 2 methyl. So, 2 methyl. We have written remaining the chain has 3 carbons. The longest carbon chain has 3 carbons. So, propane. So, 2 methyl propane. First carbon has OH group. So, 2 methyl propane 1 all. 2 methyl propane 1 all. Okay, fine. What about secondary butyl alcohol? In the same way we can give. So, the numbering should be started from this end. Then only it gets, the OH group gets the lowest possible number. If you start from here, it will get number 3. If you start from here, OH will get number 2. So, number 2 is correct. So, totally 4 carbons. OH is at second carbon. So, 4 carbons means but, single bond, and second carbon has OH. So butane 2 all, N-butyl alcohol is butane 1 all, secondary butyl alcohol is butane 2 all. Butane 1 all, butane 2 all. Only difference is what? Position of the OH group. Okay. If OH group is at the first carbon, it is N-butyl alcohol. If OH is at the second carbon, it is what? Secondary butyl alcohol. But isobutyl alcohol, 2-methyl propane 1 all. Okay. Okay, last compound, which is tertiary butyl alcohol. Tertiary butyl alcohol. This is the structure. So first you have to find out the continuous longest carbon chain. So if you start from here, 1, 2 means only 2 carbons. If you start from top to bottom means 1, 2, 3 carbons in the chain. Or bottom to top also, it has 3 carbons. 1, 2, 3. Top to bottom or bottom to top. Both are same only because in both cases, the second carbon has methyl as well as OH group. So from either from top to bottom or bottom to top, we can start. Okay, so here I have taken from top to bottom. So top carbon 1, 2, 3. So 3 carbons in the chain. Second carbon has methyl. So methyl is substituent. So 2-methyl. Methyl is the substituent. So 2-methyl. The longest carbon chain has 3 carbons. So prop. No double bond, only single bond. So and the same second carbon has OH as the functional group. So OH functional group. So suffix 2 all. At last we have written what? At the end we have written 2 all. So 2-methyl propane 2 all. Isobutyl alcohol is 2-methyl propane 1 all, whereas tertiary butyl alcohol is 2-methyl propane 2 all. So 2-methyl propane 1 all, 2-methyl propane 2 all. Just you compare these two. Already we have compared what? Butane 1 all, butane 2 all. Okay. So IUPAC namings are interesting, isn't it? Okay, right. So for these all alcohols we have given what? Structures, common name and IUPAC name. Okay. So while comparing with halo compounds, the structure and the common name for halo compounds with that of alcohols are almost similar. The only difference is in halo compounds X is present, but in alcohols OH is present. That is the only difference. But in the IUPAC name, if X only present, that X name should be written as the prefix, which is considered as the substituent. But in the case of alcohols, if alcohol is present as the functional group, then the OH functional group, the IUPAC name all is written as the suffix. Suffix means the name ends with OL. The OL should be written at the end of the IUPAC name. All. At the end, all. Okay. Okay. Right. Let us see about some aromatic alcohols. Aromatic as well as alkyl. Okay. Right. So this is actually we have written benzyl bromide. So in benzyl bromide, instead of this Br, if you introduce OH group, now this compound is called as benzyl alcohol. Benzyl group already we know very well. Okay. With benzene ring, if CH2 group is attached, then it is called as benzyl. With benzyl, with this CH2 only OH is attached. So this is benzyl alcohol. Benzyl alcohol. Common name is benzyl alcohol. IUPAC name is. Okay. You see, OH is the functional group. Functional group is attached with this carbon. So this is the main chain actually. With this carbon, both phenyl group as well as OH group, both are attached. So with this carbon, phenyl group is attached. So phenyl substituent. And OH as the functional group. Phenyl substituent, OH as the functional group. One carbon. So meth, no double bond, and OH all. So phenyl methanol. Phenyl methanol. So for benzyl alcohol, the IUPAC name is phenyl methanol. Okay, right, fine. So benzyl alcohol. Okay, right. What about this compound? Benzene ring. If you remove one hydrogen from benzene ring is the C6H6 actually. If you remove one hydrogen from benzene ring, now the C6H6 becomes what? C6H5. Instead of this hydrogen, if you substitute OH group, now this compound is C6H5OH or benzene with OH. Okay, C6H5 is called as what? Phenyl. Benzene with the loss of one hydrogen, that group is phenyl group. OH is alcohol. So this is phenyl alcohol. Phenyl alcohol is shortly written as phenol. Phenyl alcohol is shortly written as phenol. This phenol is considered as the what? Common name. Common name. Okay, right? Okay. And IUPAC name. IUPAC name for phenol. IUPAC name for phenol. So actually IUPAC name alk or aryl part. Alkyl part or aryl part. Here aryl part is there. The aryl part is phenyl group. Phenyl group actually what? Benzene. It comes from benzene. So benzene with OH group. For OH group, the IUPAC name is all. So benzene plus all, this E will be removed. Okay. So this when E comes, when O comes, here E is present. This E is a vowel, E is a vowel, O is also a vowel. Vowel won't combine. Okay. So if you remove this E, N and O, both will come. They can combine because N is a consonant, O is a vowel. So if you remove this plus, then benzenol. Benzenol. So like this only in NCERT book given. NCERT book for phenol, the IUPAC name is benzenol. What? Benzenol. Okay, right. But in some state board books, state board level books like Tamil Nadu board book, Tamil Nadu, TN board. TN board, the IUPAC name for phenol is given as what? Phenol itself. The IUPAC name for phenol is given as phenol itself. Phenol itself. Okay, right. So if you are following NCERT book, you should be strict with the IUPAC names. The IUPAC name is what? Benzenol. If you are writing NEET J like that means the IUPAC name for phenol should be taken as benzenol. But for state board books, you must follow your own state board books. For example, if you are following your TN board books means then the IUPAC name for phenol is given as phenol itself. So just you follow. Okay, right. And if benzene group has two OH groups, the two OH groups, if they are present with the angle of 60 degree, then if the angle of 60 degree, then those compounds are called as what? Ortho. The compounds are called as what? Ortho. Okay. Right. So this is actually ortho dihydroxybenzene. Ortho dihydroxybenzene. Ortho di, not chloro. Ortho dihydroxybenzene. Like this only, it has been given in the Tamil Nadu State Board. Okay. The famous common name for this compound is catechol. What? Catechol. Ortho compound is actually called as catechol. If two OH groups are present at 120 degree, then it is called as meta. If meta compound, if meta positions have two OH groups, then that compound is called as resorcinol. What? Resorcinol. If para positions have two OH groups, that is the angle between two OH groups means is 180 degree. 180 degree. If they are present just opposite to each other, then that compound is called as quinol. What? Quinol. Ortho means catechol, meta means resorcinol, para means quinol. Catechol, resorcinol, quinol. Okay. So for catechol, the common name ortho dihydroxybenzene, it has been given. IUPAC is given as what? For ortho 1,2. 1,2 dihydroxybenzene. 1,2 dihydroxybenzene. It has been given. But in NCERT book, the IUPAC name for catechol is, all are ortho, no? Okay. So catechol for IUPAC name is benzene 1,2 diol. Benzene 1,2 diol. For phenol, the IUPAC name was benzenol, and for catechol, the IUPAC name is benzene 1,2 diol. 1,2 diol. So diol. If the compound contains two OH groups, then that compound is called as what? Diol. It is called as diol. If the compound contains 3 OH groups, then it is a triol. It is a triol. In aliphatic also we can write some diols. CH2OH bond CH2OH. So this compound is a diol. Its common name is CH2CH2. It looks like ethylene. It looks like what? Ethylene. If 2 OH groups are present at adjacent positions, generally it is called as a glycol. So it is ethylene glycol. The common name is what? Ethylene glycol. And the IUPAC name is 2 carbons. So the root word is eth, single bond only. So and 2 OH groups, one is at the first carbon, another is at the second carbon. Both are OH. Both are OH means 2 OH groups are present means then what we should select? Di. So we should write di. So ethane 1,2-diol. If D comes here, E should be there because E is vowel, D is consonant. Vowel and consonant only will combine. Okay, we should not remove what? E should be there itself. There itself. Okay, so ethane 1,2-diol. So this is ethylene glycol. And if the compound has 3 OH groups, CH2OH, C bond C, so here CHOH, here CH2OH. It is a triol. It is a triol because it contains 3 OH groups. Okay. 2 OH groups means diol. Diols are commonly called as dihydric alcohols. Here the word hydric indicates what? Hydric means OH group. Trihydric alcohol means if the alcohol contains 2 OH groups, then it is called as dihydric alcohol. If it contains 3 OH groups, then it is a trihydric alcohol. Generally, it is called as a trihydric alcohol. It is a trihydric alcohol. And the common name is, the very famous common name is glycerol. Glycerol can be otherwise called as glycerin. Have you heard about glycerin? Glycerin. If you place a drop of glycerin just below, just at the bottom of your eyes, then it looks like that you are crying. Okay. In the TV serial, in cinema also, they are using glycerin for what? Weeping and for crying. Okay, because glycerol is hygroscopic in nature, it absorbs moisture. It loves moisture. If you place a drop of glycerol in the eyes, then it will absorb water from your eyes, then which will roll over your cheeks. Your cheeks. Okay. So glycerol is hygroscopic, so it is water absorbing. So glycerol otherwise called as glycerin. Glycerin tears. In cinema, they are showing what? Glycerin tears, not natural tears. Okay. Right. What will be the IUPAC name for glycerol? It has 3 carbons. So prop. What? Prop. Okay. No double bond. So an. Okay. There are 3 OH groups. One is at the first carbon, another is second, another is at the third. So 3 means tri. OH all. So propan 1, 2, 3 triol. Actually it is wrong because here T comes, here N ends. It ends with the N. It comes here T. T comes here. So N, T both are consonants. So here you have to give one vowel already which is present here. Propan. Propane 1, 2, 3 triol. Not propan 1, 2, 3 triol. It is propane 1, 2, 3 triol. Okay. So glycerol IUPAC name is propane 1, 2, 3 triol. Ethylene glycol IUPAC name is ethane 1, 2 diol. Ethane 1, 2 diol. Okay. Right. Okay. So alcohols, let us finish alcohols. Now let us enter into the next functional group, which is ethers. Which is what? Ethers. Ethers. Both ethers and alcohols have the same molecular formula, which is CnH2n plus 2O. CnH2n plus 2O. Okay, right. Okay, so already in the molecular formula, CnH2 H2N plus 2O, we have substituted value for N as 1, we have got what? CH4, and the compound was methyl alcohol, already we have seen. The same molecular formula, CH4 has no ethers because the general structural formula for ethers, how it will be means, the functional group in ethers is O. O is the functional group. The valency of oxygen is already we know it is 2. Around O, that is the valency, 2 valencies of oxygen is satisfied by 2 alkyl groups or 2 aryl groups or 1 alkyl or 1 aryl group. Then those compounds are called as what? Ethers. So ethers, the general structure will be R bond, O bond, R. These two R's may be same or different. If they are same, then it is called as simple ether. If they are different, then it is called as mixed ether. Simple ethers can be otherwise called as symmetrical ethers, and mixed ethers are otherwise called as unsymmetrical ethers. Okay. So the ether with 1 carbon atom, there is no possibility of ether with 1 carbon because there must be 2 alkyl or aryl groups. So if here 1 alkyl means at least you have to put methyl, here also 1 methyl put, so methyl 2 carbons. So the very first ether should have 2 carbon atoms. So there is no ether having only 1 carbon atom. Okay. So the alcohol with only 1 carbon atom is methyl alcohol. IUPAC name was methanol. IUPAC name is methanol, and there is no ether in that molecular formula. But the next molecular formula, which is C2H6O, already we have written the alcohol, which is C2H5OH, ethyl alcohol, the same molecular formula as ether also. So CH3O, CH3. You just count the number of atoms. How many carbons? 2. So C2. How many hydrogens? 3 plus 3, 6. So H6, only O, 1 O. So C2H6O. So this is the structure of ether, which has the molecular formula C2H6O. Okay, fine, right? And the next molecular formula C3H8O. In this molecular formula, already we have written what? 2 types of alcohols. The one was N-propyl alcohol and the another was isopropyl alcohol. We have finished. Now this C3H8O has ethers also. So total 3 carbons. O is the functional group. Total 3 carbons. How we should write? 2 carbons one side, 1 carbon this side. Or 1 carbon this side, 2 carbons this side. Valency of carbon is 4. So this corner carbon has H3. Here 2 means H2. Here 1 means H3. Here 1 means H3. Here 2 means H2. Here H3. Okay. Right. So this is actually ethyl methyl ether. Ethyl methyl. Let us write the common name later. Okay. Right. Okay. I just want to ask one question. Are these same or different? Here first ethyl and last methyl. Here first methyl at the end ethyl. Are they same or different? Means they are same only. They are same only. Okay. Because while writing the name, first let us write the common name for this ether. Methyl, actually the common name for ether should be ending with the word ether. Okay. Alkyl ether. Alkyl ether. 2 alkyl groups must be written. If the 2 alkyl groups are same, then we can give the word dialkyl ether. If they are different, then they should be written separately. While if 2 different alkyl groups are present, then you have to follow the alphabetical rule also. Alphabetical rule. Okay, right. So by keeping all these rules in mind, let us start giving the common names for these ethers. So methyl ether. So methyl, same type of 2 alkyl groups. So dimethyl, so ether. Methyl ether, dimethyl ether. What about this? This is ethyl, this is methyl, O is ether. So ethyl, methyl, ether. Ethyl, methyl, ether. And for this compound, methyl, ethyl, ether. Methyl, ethyl, ether. Is it correct? Is it correct? No. This is wrong. Because in this case, we didn't follow the alphabetical order rule. Here M is written first and followed by E, ethyl. So always ethyl should come first, followed by methyl, because in alphabets E comes first, then what? M. Okay, right. So while writing structure, you can write like this or like this, but while writing name, you should write only ethyl methyl ether, not methyl ethyl ether. But yeah, writing of structures, these two are correct. This is correct, this also correct. But common name, this only correct, this is wrong. Okay, so ethyl methyl ether. And what about butyl? C4H9. So butyl, OH alcohol. There are 4 different types of butyl alcohols we have written. And what about ethers now? There are 4 alcohols in C4H10O. Ethers, let us see how many. Ethers, let us see how many. There are 4 alcohols already we have seen. Ethers, let us see. So ether means O, 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 O. So bond. The valency of oxygen is 2. 4 carbons. 2 carbons this side, 2 carbons this side. Or 3 carbons this side, C, bond C, bond C, bond O, 1 carbon this side, 1 carbon this side. Or 1 carbon this side, here 3 carbons but 1 carbon at a branch. Like this we can write. Is there any other possibility? No. So there is no, the 4th ether, only 3 ethers are present. 4th ether not present. So C4H10O molecular formula has 4 alcohols. C4H10O molecular formula has 4 alcohols and 3 ethers. 4 alcohols and 3 ethers. So totally how many compounds are present? Totally 7 compounds are present. Among 7, 4 are alcohols, 3 are ethers. Okay. Let us complete the valencies. So here H3, here H2, here H2, H3, here H3, here H2. For this carbon, H2, here H3, here H3, 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 here 3 bonds, so H. So these are the structures of these 3 ethers. Let us give the common names. So while giving the common names to ethers, what we should follow? The name should end with ether. Before the name, alkyl groups must be written in alphabetical order if they are different. If they are same, then the word di should be added. Okay, so see, this is ethyl, this is also ethyl, ethyl, ether. So this is diethyl ether. So this is diethyl ether. Okay, and the second compound, this is methyl, this is N-propyl. Okay, you see this is N-propyl, you know? Yes. So this compound is methyl N-propyl ether. This ether is what? Methyl N-propyl ether. Which should be written first? Methyl or N-propyl? M comes first. Then what? P. Propyl, P. The letter P should be noticed, not N. We should not consider this N. We should consider only P from propyl. Small p from propyl. So M comes first in alphabet. So methyl N-propyl ether. And for this one, methyl, this group is what? CH is attached to 2 methyl groups. What is the name of that group? Isopropyl. So methyl isopropyl. So methyl isopropyl ether. Methyl isopropyl ether. Okay. So we have given structure and common names to some ethers. Okay. Right. And let us write some aromatic ethers also. Aromatic ethers also. Here. Aromatic ethers. Okay. So this is ether. O is there. With O, methyl group is attached. So this is ether. O is there. With O, ethyl group is attached. This is ether. O is there. With O, one more benzene ring is attached. I can write like this. Benzene, O, benzene ring. Okay. This is purely aromatic ether. These are alkyl ether. Alkyl ether. These two are alkyl ether. Let us give the common names. This is methyl, this is phenyl. So methyl phenyl ether. Methyl phenyl ether. Methyl phenyl ether. Okay. This methyl phenyl ether is otherwise simply written as what? C6H5OCH3. Instead of benzene ring, we can write what? C6H5, which is called as phenyl group. So this is the common name. This is the common name. And for this compound, ethyl phenyl ether, ethyl phenyl ether, ethyl phenyl ether. Okay, and simply we can write what? C6H5O C2H5. And for this compound, phenyl ether, so diphenyl ether, diphenyl ether, diphenyl ether. Simply we can write C6H5 bond O bond C6H5. Both are diphenyl ether. Okay, right. Methylphenyl ether, otherwise famously called as anisole. Methylphenyl ether is otherwise famously called as what? Anisole. And ethylphenyl ether, it is the elder brother of anisole, this compound. It is called as phenol. Phenetole, phenol. Phenol and anisole, let us say them as brothers. Anisole is the younger brother and phenol is the elder brother. Okay, so the elder brother of anisole is phenol and the younger brother of phenol is anisole. Phenol, anisole. Anisole, methylphenyl ether. Phenol, ethylphenyl ether. Okay, fine. Let us give IUPAC name. Let us give IUPAC name. IUPAC name very interesting for ethers. So we have to select the root word, that is alk. Here there is a chance for two different alk groups. The alk should be from longest carbon chain. The alk should be from longest carbon chain. Okay. Okay. And with alk we should add oxy. Sorry. We should first select what? Alk. Alk. Okay, this alk not from the longest carbon chain, it is the shortest carbon chain. Shortest. The alk should be shortest carbon chain. With alk, we should add the word OXY, oxy, which represents ether. Okay, after oxy, we should write alkane. Alkane. Okay, this alkane must be from longest carbon chain. Longest carbon chain. Okay, so the name is actually alkoxyalkane. The name is actually what? Alkoxyalkane. This alkane part must be the longest carbon chain and alk part must be shortest carbon chain. Keeping this in mind, let us give the IUPAC name for ethyl methyl ether. You see, ethyl methyl ether. Here methyl, here ethyl. Methyl contains only one carbon, ethyl contains two carbons. So which is the longest carbon chain? Ethyl. So the ethyl is longest, it has two carbons. So the name alkane, the two carbons alkane is ethane. The alkane which has two carbons is ethane. Then this is the shortest root word, meth. One carbon means meth plus oxy, methoxy or methoxy ethane. If you are writing this compound like this also means, then for this also the same IUPAC, methoxy ethane. This is the longest carbon chain. So two carbons, so ethane. This is one carbon, shortest, so methoxy. So methoxy ethane. We should not write what? Ethoxymethane. Ethoxymethane. If you write ethoxymethane, then it is wrong. So always keep in your mind that always the larger part will have the smaller part. Not oppositely. Always the larger part ethane will have the smaller part methoxy. Logically also it is okay. But the smaller methane has ethoxy. If you are saying like this means that is wrong. Simply you can understand this like this. You can place a bicycle on a lorry. You can place a bicycle on a lorry. Can you place a lorry on a bicycle? Is it possible? Impossible. Like that only. Larger part will carry the smaller part. Smaller part will not carry the larger part. Okay, right. Fine. And for dimethyl ether, it is no problem. Both are methyl. So methoxymethane. Methoxymethane. Diethyl ether also it is there is no problem. Both are ethyl. So one is alk, another is alkane. So alkane is ethane, alk is eth. For O it is oxy. So ethoxy. So ethoxy ethane. Methyl N-propyl ether. This propyl is the longest carbon chain. So propyl should end with propane. And methyl is the shortest. So root word is meth and oxy. Ethoxy. But propane has total 3 carbons. 1, 2, 3. With first carbon only, this methoxy attached. First carbon only, methoxy attached. So 1 methoxypropane. So here numbering should be given. So 1 methoxypropane. In the same way, here this is isopropyl. Longest part, isopropyl, 3 carbons. So propane. 3 carbons, the alkane part. So propane. In isopropyl, the second carbon has this methoxy group, meth plus oxy, methoxy. So methoxypropane. Second carbon has, so 2 methoxypropane. So methyl and propyl ether, 1 methoxypropane. Methyl isopropyl ether, 2 methoxypropane. What about sir, anisole? Anisole IUPAC. Which is larger part? Benzene or methane? Benzene. So benzene. On benzene, methoxy is present. So methoxybenzene. Can we write phenoxymethane? Phenoxymethane is wrong. Methoxybenzene is correct. So here also ethoxybenzene. Can we write phenoxyethane? No, phenoxyethane is wrong. Okay, so lorry cycle lorry முடியாது. Benzene மேல ethoxy. On the benzene we can place ethoxy, but on ethane we can't place phenoxy. Okay, fine. Now this compound diphenyl ether or biphenyl ether, bi, both can be given. Bicycle, two-wheeled vehicle, bicycle. So bi is equal to di. Okay, fine. So this is, both are phenyl groups. So we can simply give phenoxybenzene. Like methoxymethane, ethoxyethane, what? Phenoxybenzene, simply. Okay. So by this, ethers over.